Good morning students, welcome to our next lecture of data structures and algorithms. Till now we have studied about different types of sorting techniques, and in today's lecture we will study about heap sort. That is, first we will study what is the meaning of heap, then we will see that how we can sort a heap using the following example. So starting with the introduction of heap, it is a technique which sorts the elements of array that represent a tree with a special property. That means heap sort is a technique, and this technique sorts the elements of the array. Suppose that we are having these elements and these elements are stored in an array. So what we will do, we will sort all these elements of the array using the heap sort technique, and this heap sort technique have a special property. We will study this special property with a special property. Okay, we will apply this special property while solving this question. Now a heap is defined as a balanced binary tree. That means a heap is a balanced binary tree. We will create a balanced binary tree. Balanced binary tree means the root node of the tree is the maximum value of the tree, and on the left side, that means the left subtree of the root node will be the value less than or equal to the root node, and the right subtree will contain the values greater than the root nodes. So that's why we are calling it a balanced binary tree. So a heap is defined as a balanced binary tree in which the value of each node is less than or equal to the value of the parent node. That means the value of each node is less than the value which are less than the parent node will come on the left side of the root node. That means the value less than the parent node will be displayed or inserted on the left subtree of the root node, and the values greater than the parent node will be inserted or stored on the right subtree of the root node. This implies that root of the binary tree has the largest element in the group, in the heap. So the property, the special property which we are talking about is the root of the binary tree in heap sort. The root of the binary tree in heap sort will be the largest element in the heap. The largest element in the heap will be the root node of the binary tree which we will be creating using the heap sort. And we will study this special property. That means the largest element of the heap will be the root of the binary tree. We will study this property by solving this example. Now talking about the types of heap sort, we are having two types of heap sort. First one is max heap and second one is min heap. Max heap means root node with the largest element, and min heap means root node with the smallest element. Root node with the smallest element. So max heap means the heap, the binary tree, the balanced binary tree with the root node as the largest element of the tree, and min heap means the root node with the smallest element of the balanced binary tree which we are creating. So these two are the types of the heap. Now let's see that how we can create a heap, or how we can insert elements in a heap. We will study this operation of heap sort, that is creation of heap or insertion in heap, using this following example. So let's start with the example. We are having these elements of array, and using these elements of array we have to create a balanced binary tree. A balanced binary tree means we have to create a heap that is sorted. A sorted heap is known as the balanced binary tree. So we have to create a heap using all these elements of the array, and we will be sorting all these elements while inserting in the heap. We will be sorting, applying, first of all we will insert the element in the tree, and then we will sort the element according to the condition, that is the property. Property means the minimum element, the maximum element. We will apply all the conditions after inserting the elements. So let's start with this example. The first step, in first step we are having 44 as the first element of this array. So we will make 44 as the root node of the tree. So 44 will be known as the root node of the tree. Now in second step we are having next element 30. Insert 30 on left of 44, that is the root node, on left of 44, and compare both. Now what we will do, we will insert 30 on the left of root node 40. Now after inserting 30 on the left of root node 44, we will compare both the elements. 30 is less than 44. That means the special property which we were discussing, that the root node will always contain the highest value. So from both of these we know that 44 is greater than 30. That means no need to interchange the position of the elements. Now we will insert the next element. The next element that we are inserting is 50, because our next element is 50. So insert 50 on right side of root node, that is 44, and compare. Now what we will do, we will insert 50 on the right side of the root node, that is 44. Now after inserting the element 50 on the right side of the root node, we will compare the newly inserted element, that is 50, with the root node. Since 50 is greater than 44, 50 is greater than 44, then what we will do to fulfill the special property of the heap sort, that the root node will always contain the highest element of the array, what we will do, we will interchange the positions of both these elements, that is 44 and 50, and our new tree will be 50 at the root node, 30 on left side, and 44 on the right side of the root node. So this will be our new binary tree. Now in step 4, we are having next element as 22. So what we will do, we will insert insert 20 on left side of the element 30, because this level of binary tree is complete, and in heap sort we need a balanced binary tree. So to balance this binary tree, we will insert the next element on the left side of the node 30. So we will insert, this is our root node, then on left side we are having 30, on right side we are having 44, and on left we are inserting 22. Now we will compare 22 with 30. Since 22 is less than 30, so no need to shift. Since 22 is less than 30, that means there is no need to shift these elements. They are at its proper place. In next step, we are having next element to be inserted is 60. So insert 60 on right side of node 30, because we are creating a balanced binary tree using heap sort. So to balance this tree, this binary tree, we will insert, after inserting the left child of node 30, we will insert the right child of node 30. So we are having root node as 50, on left side we are having 30, right side we are having 44, then on left of 30 we are having node 22, and on right of 30 we are inserting 60. Now we will compare the element, newly inserted element, that is 60, with the parent node of 60. That means 60 is greater than 30. So we will shift 60 and 30. That means now 50 is root node. We will interchange the position of the nodes 60 and 30, because 60 is greater than 30. That's why we are changing the position of 60 and 30. 60 will become the parent, and 22 will be the left child, and 30 will be the right child, and on right of 50 we are having 44. Now what we will do, we will compare 60 with 50, because our special property states that the root node will always contain the largest value of the array. So 60 is greater than 50, so we will interchange the values of 50 and 60, and our new tree will be, and our new tree will be 60. On left side we are having 50, right side we are having 44, and then 22 and 30. So this is our newly created tree. Now in step 6 we are having next element to be inserted is 55. We are having next element to be inserted is 55. So we will insert 55 on right side of 44, so that we can get a balanced binary tree. So we are having root node as 60, left child 50, right child 44, its left child 22, and right child 30, and left child of 44 is now 55. Now what we will do, we will compare 55 with 44. Since 55 is greater than 44, then we will interchange 44 and 55. So our new tree will be 60, 50 on left, 55 on right, 22 left child of 50 and 30 right child of 50, and 44 as left child of 55. So this tree we have got after interchanging the position of 44 and 50, because 55 was greater than 44. Next element to be inserted is 77. So 77, we will insert 77 on sorry, this was left, on right side of 55. We will insert 77 on right side of 55. So our tree will be 60. Let's make it 60 as the root node, 50 its left subtree, 55 right subtree, 22 as child of 50 left child, and 30 as right child of 50, 44 as left child of 55, and new element that we are adding is 77 as right child of 55. Now we will compare 55 and 77. 77 is greater than 55. That means we will interchange the position of 77 and 55 to make it a balanced binary tree. So new tree that we are creating will be 50, 77, 22 and 30, 44 and 55. Now we will again compare 60 and 77. Since 77 is greater than 60, so we will interchange the positions of 60 and 77. We will interchange the position of 60 and 77. Let me show it here. So after interchanging the position of 60 and 77, we are getting 77 at the root node, then 50 its left child, 60 as its right child, 22 left child of 50, 30 as right child of 50, 44 as left child of 60, and 55 as right child of 60. Now the next element that is to be inserted in this binary tree is 55. So in step 8 we are inserting 55. Since 77 is at level 0, level 1, level 2. So till now level 2 all the nodes are balanced. So we will insert 55 on left of node 22. That means 77 on left, 50 on right, 60. Left child of 50 is 22. Right child is 30. Left child of 60 is 44. right child is 55 and we are inserting the new element 55 on left of 22. Now we will compare 55 and 22. 55 is greater than 22. Then we will interchange the position of 22 and 55. Then we will again compare the value of 55 and 50. Since 55 is also greater than 50, then we will interchange the position of 55 and 50. Then further we will compare the value of 55 with 77. Since 55 is less than 77, that means no interchange. So the final tree that will be created is 77 as the root node. On left we are having 55, right 60. On its left we are having 50. On its right we are having 30, 44, 55, and on its left we are having 22. So this final tree gives us that the highest element, the largest element at the root position of the tree. 77 is the largest element among all these elements, and this largest element comes at the root node of this balanced binary tree, and this special property has been fulfilled. So this was the creation of heap or insertion in heap. In this way we can create a heap using the elements of the array, and as we are inserting the elements of the array in this heap, we are sorting them also, so that we get the largest element at the root position of the tree. So this was all about heap sort. I hope you all have understood. Thank you very much.